Okay, so now we have our short caches, and we'll make it bigger later. Let's do another kind of render, but this time a OpenGL render. So OpenGL is this real-time viewport used in video games and stuff a lot too. Now there is no OpenGL node here. You can see I already put a ROP fetch. If we make a ROP network in here, we can put an OpenGL renderer in here. And that's what we want to use. So I'm going to copy this and then say that's what we want to do, is that one. But in any case, we need to set this up. So what do we want to render? Kind of like the Mantra renderer, there's this list of objects to render. So why not render that preview thing? The one that is this actual building here. So, okay, that's good enough. We want a frame range. We'll just say, have it do RF end. That's the number here. I think it means like relative frame end or something like that. And it'll do RF start here. So 1 to 24. The camera is already set to camera 1, but obviously change it if it is necessary. For the output, where is this going to go? Let's put it in data / PDG / the sim, which I'll go back and do in a minute, the wedge, which we'll do in a minute, and I'll just say the OpenGL, or we'll just say, we'll call this just the render. So PDG / render actually, and then the last frame will just be also render. Render dot frame dot, and we'll just use a PNG file to make sure that we don't need to do like EXRs, we don't need anything hardcore, you just preview renders anyway. But so something like this, and we need to actually populate the other thing. So the sim version is this, so copy the sim, that's the V one here, so go paste absolute references, and go get the piece, or rather not the piece, we want the wedge index. So backtick, and then @ wedge index. So once again, middle click to make sure it makes sense. So it's in our data area, our new PDG sub area, renders the sim version, which is 0, the wedge version, which is whatever wedge we currently have clicked, and then the current frame number just rendered to that. So that's good enough. While we're here, change gamma to 2.2. You know, in many ways, like let's say if I were to render just a couple of frames in the viewport, or rather in the flipbook, this is the kind of render we're trying to make, is this kind of render. It's just a picture of the OpenGL viewport. So I want it to look like this as close as possible. This here is the gamma, it's 2.2. If it's at 1, it looks like this. So 2.2 is the default here. For some reason, it's 1 here. Change this to 2.2. So that should be enough for that. Display options. We don't need high quality lighting or anything. Again, we just want it to look plain and normal here. And is there anything else we need in here? No, that's probably fine. So we can render a frame ourselves if we want. We could say render current frame, click render, and let's see what that looks like. Go back to frame range so we don't forget. So let's see. Back here we have PG, render, version 0, wedge 2, and there it is. And it looks like that. You can see it was lightning fast because of course it should be. And it looks like what we have here. So we can be satisfied that that works now. So to finish setting this up, our ROP fetch here should say, let's see, all frames in one batch? Hard to say. If we say all frames in one batch, much like a simulation, it'll again spin up one copy of Houdini per wedge and go through it. It renders pretty fast, so it actually might make sense rather than starting and closing Houdini. If we did 1 frame per batch, then every single one of these frames will have to start a version of Houdini, render an image, and then close. The startup time of Houdini is long enough that we could have rendered probably like 20 frames. So this is not actually the most efficient thing we can do. Doing all frames in one batch is probably not efficient either, because we might just have idle processors. So it'd be hard to say what is the actual ideal here. I'm going to end up just saying all frames in one batch, or we can again break it up into like do 30 frames in one batch or 60 frames, because I know we're eventually going to do a 120 frame sequence. I'm just going to say let's break it up as 60 frames per processor. You can play with this. I mean, nothing bad will happen if you do something too low or too high. It just may be a little less efficient, but that should be fine. So, oh, and this is evaluating doing a frame range. So actually, if this is being set to do a frame range, we need to make sure that this is not also doing a frame range. So change this to current frame, and it will render whatever frame this is currently on. If we're ever not sure about that, when we go to run it, we look how many of these things did it make. Apparently it made a lot. So let me turn that off. Let's go to delete this node's results, do Shift V again. So even going to all frames one batch didn't fix it, which it shouldn't have. I just wanted to make sure. So it seems we're getting here, it's doing one of these per that. Let me think about this for a second. So I think I got it backwards. I think this should be set to single frame, and this should be set to frame range. So let's try that. So save, Shift V this, and there we go. So now it's doing 72 frames again, which is what we wanted. Cool. And then to go back to what I had it doing. Oh yeah, 60 frames still. Okay, that was right. Shift V, let it run. We'll certainly be able to test if it worked correctly. We'll see those images show up here. That one's already done, I guess. I'll just delete that one just in case. That was from our test before. I'm going to try one more time and see if we have these multiple processes showing up. Oh, no, they're there. It's funny. Anyway, there they are. Houdini FX 4. So we have our copy of Houdini running, and then we have 1, 2, 3. These are the sub 3 processes running. And we can see how, we're going to have to load up all the memory for each on top of the one that we already have here. And there they go. You can see they're going quickly because it's just an image. It's not a simulation this time. So hopefully we'll see them showing up in here in a way that makes sense. And it looks like I can already see kind of at a glance that it's correct. But this being Windows, it'll just load the default photo viewer, and if I just click through these frames, I can see that it's working. And that they should be different between the different wedges. I can be reasonably assured that they are. So here's frame 24 of one of them. And here's frame 24 of a different one. So hopefully they'll look different. And they are. Great. So it rendered the right ones. And again, this works because clicking on one of these nodes says it knows that this work item was the third wedge. It was apparently the 22nd frame of the third wedge, meaning wedge number 2, because it goes from 0 to 2. And then this one also, it traces the path out further. This one's saying, I'm rendering frame 22 of the second wedge. So it all trickles down really nicely. Awesome. So there's our images. Let's put some text on it to say what the wedge value was.